Okay, from the top, let's take a look at the rules. So when multiplying with the same base, we add the exponents. When dividing with the same base, we subtract the exponents. When we have exponents to exponents with brackets, we multiply or distribute the exponents. When we have negative exponents, we bring it to the top and make the exponent positive, or vice versa, bring it to the bottom and make the exponent positive, or whichever, with a whole bunch of examples off to the right with what to do and what not to do. And then the little example of when you can flip it. What happens when we have coefficients? Go back to grade 9, understand what to do with the numbers. It will more easily allow you to do this. I literally copied the grade 9 review sheet, printed it here, and changed all the numbers to x's. Further down the page on the left, x to the 0 is 1, x to the 1 is x, 1 to the x is 1, 0 to the x is 0, and x can't equal 0. Be careful, some of those rules are asterisks. Below, change of base, 8 equals 2 cubed. That's a grade 9 rule, but we can do it this year and next, etc. And then our new fractional exponents and a bunch of theory off to the right. So, now let's take a look at radicals review. The next page, print it off, flip it over. So, some logic at the top. 5 squared is 5 times 5, which is 25. And the square root of 5 times the square root of 5 is the square root of 5 times 5, which is the square root of 25, which is the square root of 5 squared, which is 5. Like, come on. Just like 5 squared is 25. The square root of 5 is 25. Like 5, whichever. Very simple. Okay. Either way, top right, we have the index, the type of radical, like square root or cube root. And we have the thing underneath the root, the radicand. And we call the whole thing the radical. So we've got some cool stuff to do with multiplication off to the right, but we'll do more of that in grade 11. Some remembers in big blue. Can't square root a negative. An example off to the right. Can't even root a negative. An example off to the right. They do not exist. You can cube root a negative. An example off to the right. You can odd root a negative. The example off to the right. The English sentence is off to the right. You may not put a negative into the square root. You may put a negative into a cube or odd root. Remember, the square root of a number cannot equal a negative, and the even root can also not equal a negative. So some things that you may do this year. Oh, off to the right, big blue, our fractional exponent law that we went over at the end. Again, go through each of the individual parts one at a time. This is a review sheet. So, little bit for the super achievers. If we square root both sides, the answer is plus minus. A whole bunch of nerdy stuff off to the right. And then a little bit on multiplication. So we're going to do a lot more multiplying in the future, but we kind of already took a little bit of a look at it when simplifying the roots. Either way, check your answer, and you can like figure out math, or you'll be a Nobel laureate. You got all the letters off to the right. And then we have how we can simplify square roots and cube roots using prime factorization, or perfect squares, or perfect cubes. Okay.